directional derivatives, if we let w be a function x, y, so two variables, and we're going to set u to be a unit vector in R2 with the components u1, u2, then the directional derivative of f at xy in the direction of the unit vector u is denoted by du f of xy, which is equal to the limit of, as h tends to 0, of f of x plus h times u1, y plus h times u1, minus f of xy, all divided by h. If f is a differentiable function of two variables and u is the unit vector u1, u2, then the directional derivative is the partial derivative of f with respect to x times by u1 plus the partial derivative of f with respect to y times by u2. Now, we already know that the gradient of f, so grad of f of xy, is equal to the partial derivative with respect to xy, partial derivative with respect to y as a vector. So this means that we can rewrite our directional derivative as grad f of xy times by the unit vector u. So let's have a look at an example. Say we have a function in three variables. So f of x, y, z, which is equal to the natural log of xy plus yz plus zx at the point 1, 1, 1. So x equals 1, y equals 1, z equals 1. And we want it in the direction from 1, 1, 1, 2, minus 1, minus 2, 3. So the first thing we're going to do is we want to find u. So this is the unit vector. Then we want to calculate the gradient of f at the point 1, 1, 1. And then we're going to do the dot product. So it's the gradient dotted with the unit vector u. So if we find the partial derivative of f with respect to x, it seems like a nice step to do first, then this will give us y plus z over x, y plus y, z plus zx. And this is part of our step 2, the first part. In order, we're going to find the gradient of f. The other things we will need to do is to have the partial derivative with respect to y. And that is going to be x plus z all divided by xy plus yz plus zx. The final thing we're going to need is the derivative of f, partial derivative with respect to z, which is going to be y plus x divided by xy plus yz plus zx. So now we've got these key points, then we can start with our steps properly. So, step 1, we're going to work out u. Now, because we have 2 points, we need to find the gradient of these points. So the vector between them. To do that, we're going to take this set of ordinates here and subtract this one. So u is going to be -1, -1, which is -2. -2 take away 1 is -3, and 3 take away 1, which is 2. Now, we specified that u had to be a unit vector. So, to make it into a unit vector, we're going to take the square root of the component squared, so -2 squared plus -3 squared plus 2 squared, which is root 17, and then we are going to divide all of these elements by root 17. So that will give us u is equal to -2 over root 17. Oops. -3 over root 17 and 2 over root 17. Back a bit bigger. Okay, so we've worked out what the unit vector u is. The second step, do this in green, is to find the gradient. Now, grad f we know is partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. Now, we've already worked these out here on the left hand side. So all we're going to do is sub in the values 1, 1, 1. So the gradient f at 1, 1, 1 is equal to 2/3, 2/3, 2/3. And this makes sense because we have two variables added together and the sum of the variables multiplied together, and as all the variables are 1, that gives us 1 variable plus 1 variable is equals 2, and then 1 plus 1 plus 1 is 3. So there's all going to be 2/3. So the third step is to dot the two facts. So we've got u and the gradient. I have to move the screen up a bit. So step 3 is grad f times by u. So that gives us 2/3, 2/3, 2/3 multiplied by -2 over 17, sorry, root 17, -3 over root 17, and 2 over root 17. This gives us -4 over 3 root 17 minus 2 over root 17 plus 4 over 3 root 17, and that equals -2 over root 17. So that is the directional derivative of our function f, which is ln of xy plus yz plus zx at the point 1, 1, 1 in the direction from 1, 1, 1 to -1, -2, -3. And that is how you calculate directional derivatives. Thank you for watching.